Hello everyone, my name is Nadya Myesha and I'm a representative of Group 36, and here we are going to discuss our final project, which is the GPS and GSM based tracking system with data logging. Next. Okay, here our group presents a really simple project, which is a very practical Arduino-based vehicle tracking system using Global Positioning System, or GPS, and Global System using GSM modules. GSM module with a SIM card used here is used for the communication between the system and the vehicle. The logger that is also in the system is very inexpensive to make and can pretty much go to most places to give you a detailed record of your travels. Now the system can be installed or be hidden in your vehicle. After installing the circuit, you can easily track if your vehicle is stolen by using your mobile device. You can also use this application to track any moving vehicles, such as a bike, a motorcycle, or even a car. Next.
Okay, so my name is Renaldi Yoriz, and now I will explain to you about the component of this project. So the Proteus simulation, there are several components that are used. The first one is the Arduino Uno. Arduino Uno is a microcontroller board based on the IAT Mega 328P or datasheet. It has 14 digital input-output pins, of which 6 can be used as PWM outputs, 6 analog inputs, a 16 MHz ceramic resonator, a USB connection, a power jack, an ICSP header, and a reset button. It contains everything needed to support the microcontroller. Simply connect it to a computer with a USB cable or power it with an AC/DC adapter or battery to get started. Next is the SD card reader module. An SD card reader is a device that allows the files on an SD memory card to be accessed. This type of reader can be an external accessory or it can be built into a larger device. SD card can be used with a variety of devices, such as cell phones, computers, and digital cameras. And after that, it is the GPS module. GPS modules are tiny processors and antennas that directly receive data sent by satellites through dedicated RF frequencies. From there, it will receive timestamp from each visible satellites, along with other pieces of data. If the module's antenna can spot 4 or more satellites, it's able to accurately calculate its position and time. And last but not least is the SIM900D, which is a complete quad-band GSM or GPRS solution in an SMT module, which can be aimed in the customer applications. Featuring an industry standard interface, the SIM900D delivers GSM, GPRS, performance for voice, SMS, data, and fax in a small form factor and with a lower power consumption. Next.
Okay, hello everyone. My name is Sanditya Larope Sutanto, and now I will explain a little bit about the overview of the construction or the circuits of our device. Okay, so of course we are using Arduino Uno here, and we use some of its pin. First, in pin GPO0, we use it for the GPS module to transfer data from the GPS to the Arduino. And then there are some logger here, the Arduino serial monitor and the GSM serial monitor in their respective pins. And then as you can see here, there is a SD card reader to keep the logged data. And then here is the SIM900D or the SIM card, the GSM module connected to pin 8. Okay, thank you. Next.
Okay, my name is Edrian. Now I will explain to you the code for the Arduino Uno. At first, we use 4 different libraries. The first one is software serial. It is to connect the GSM module in pin 8, and the next one is Tiny GPS library. It is used so that we can use the GPS module. And then the third and fourth one is SPI and SD library. This is used for the SD card reader. Next, we create an instance for the GPS and the file, and then we start to set the pins for the software serial. In that case, as before mentioned, we use pin 8 for the receiving end from the GSM module. Next, for the void setup, we begin the serial for the GSM module and the serial port at baud rate of 9600. And then next we initialize the SD card reader, and then initialize the GSM module to SMS mode. And then here we present to you that the code for the format for the mobile numbers. Here we only use X for the example for the mobile number, but actually you can use your personal or the target number so that you the data logged by the tracker can be sent to your mobile number. Next, in the void loop, the first thing we type is the bool new data. This is for the GPS tracking. So if the tracker sends a new location, it will set the new data to true, and then after getting the GPS position, it will send to the serial so that we know the coordinates for the tracker. Next, we print what we want to send to our mobile number, and then with the command of char 26, it is a command for the GPS tracker, for the GSM to know that it is the end of the message. And then next, after we send the message, we log the data to the SD card. We use my file before for the instance, and then with the myfile.println, this is the data that will be logged, and then we close the file, and then if the write is successful, there will be printed done. If not, it will send an error for opening the coordinate.txt. And then if the GPS is wired wrongly, or the RX and the TX pin is not connected properly, it will only print 0 to the Arduino serial monitor. So next, I'm going to share to you the simulation. Okay, now for the simulation, we can press the run button here. And then there will be 2 virtual terminals that will pop up. So if you see on the GSM virtual terminal. First, we set the GSM module to SMS mode, and if it is successful, it will send an OK to the virtual sign, the virtual terminal, and then next, 80 plus CMGS equals to the number that you will send the message to, and then arrow will pop up here, and then the latitude and the longitude. Here is the message that we want to send. And the plus CMGS 01 is the code for ending the message. As you can see here, the message is sent. And then if you see for the Arduino virtual terminal here, the GPS tracker at first will load the latitude and the longitude coordinates. And if the GPS module success at getting the coordinates, it will be logged in the SD card. And here we can see that in the SD card is the latitude and the longitude of the tracker. So for the operation of this circuit, I set it to have a delay of 20 seconds so that it will not bombard the GSM system. So this is our presentation for today. Thank you very much.